I like big O and I cannot lie. Welcome to the Techie Tessie channel. My name is Tess and today we're going to be talking about big O notation. Before we get into the video, if you haven't watched parts 1 and 2 of our Data Structures and Algorithms series, I'll link them above. Big O is used to determine the efficiency of algorithms, and we determine the efficiency of algorithms by two factors: time complexity and space complexity. Time complexity is how much time an algorithm takes to run, and space complexity is how much space or memory an algorithm requires to run. The time complexities we're going to be looking at today are constant time, which is read as big O of 1, linear time, which is big O of n, and quadratic time, which is big O of n squared. So first we'll look at constant time, which means that regardless of how much input is put into the algorithm will still take the same amount of time to run. So for example, an example of an algorithm which runs in constant time is adding elements to an array. If you add an element to an array, no matter how many elements are in that array, it will still take the same amount of time to add an element. Next, we'll look at linear time, which means the time it takes for an algorithm to run is directly proportional to how much input is put into the algorithm. An example of this would be traversing or looping over an array. So if you have 2 elements in your array, it'll take 2 units of time to run. 4 elements, it'll take 4 units of time. So as you can see, the time steadily increases as the input steadily increases. Next, we'll look at quadratic time, in which the number of inputs put into your the time it takes for your algorithm to run is the number of inputs squared. So if you have 2 elements inputted into your algorithm, it will take 2 squared, 4 units of time to run. An example of this is traversing over a 2-dimensional array. We have created a big O repository on the Techie Tessie GitHub page, which I've linked in the description below, and it contains lots of resources and code examples of the time complexities we've discussed today. I hope you found this video helpful. Keep the code coming, be sure to like and subscribe, and I'll see you guys next time.